Dear students, in here we are going to discuss about the lesson 1 in your year 11 book, algorithm. Under that I am going to discuss about the flow chart and the pseudocodes. Now this is one of the very important lesson. Even you are going to the A level ICT, this is also very important one. So therefore learning this one is very useful if you are going to do programming in future as a software engineer, or if you are going to work as a programmer. This one is very important section, and this is not difficult one. Actually there are a lot of questions in the exam paper, especially there are some MCQ, and again there are essay type full question is there. Therefore you can easily get the marks by understanding this lesson. Now in here I'm going to cover this section. Initially I just introduce what is an algorithm, and then we'll discuss what's the purpose of this algorithm and why are we learning these algorithms. Then we'll discuss how to represent these algorithms, how we are going to write these algorithms. Under that we discuss the two methods. So there are two methods that we can use to write the algorithm. One is a flow chart, other one is pseudocodes. So we discuss both methods to develop the algorithms. Then the next section in this lesson is the control structures. So we are looking at here mainly three control structures. One is a sequence, selection, loops. Under the loops we'll discuss 3 loops, while, for, repeat. So those are the sections that we are going to cover in this lesson. Now initially we want to know what is an algorithm. As you know, when we are discussing the systems, now these algorithms are developed when you are going to develop the systems. As a software engineer or programmer, when you are going to develop the systems, we need to develop the algorithms. Now we have learned a system. What is a system? System is collection of subsystems where there are some subcomponents which they are working for some specific tasks. So all a system has a collection of subsystems which are working together to complete a specific task. In the systems mainly there are 3 components. We have discussed previously what are the 3 components in the systems: input, process and outputs. So inputs are the one which will input maybe some numbers, some materials are the inputs, and this process is the one which will convert these inputs into the outputs. The outputs are the results that you will get after process. Now this process, what is the process? Now this process is the one which will convert the inputs into the outputs. To do that one, here there are a set of steps. Here these steps. Now this process, remember, are the one which will convert the input in the outputs. So here there are some steps. Those steps what we call the algorithms. Once you follow these steps in the algorithm, what happen? This will be converted into outputs. So when the problems are going to be developed, we need to identify the main components and subcomponents, and each component should identify the inputs and outputs and the process. This process is the one which will be converted into as an algorithm. So that describe the steps to convert the input into outputs. So if you take a very simple example, making a tea. Now you can see making a tea, we have some inputs. What are the inputs? The sugar, water, tea. And what's the output we want? We want to have a cup of tea. Then to make a tea, there are some steps. So this is what we call the process. Now for this process is the one which will convert input into outputs. That means these materials will be converted into tea. So to make that conversion, here there is a process. Now basically process means set of steps. We need to follow some steps in order. Remember, this order is very important. We need to follow the order. So this is the order given. So you can see, to make a tea, what you have to do, first you have to boil the water, put the tea in the bottom of the cup, add the hot water, like the steps are defined. Now you can see this is the process. So this process we describe by steps. Then this is what we call the algorithm. Once you follow this algorithm, you will get the desired outputs. So then basically you can understand what is an algorithm. Algorithm define a sequence of steps. You need to complete this step in order. and once you complete these steps you will get the desired outputs. So in very simply, algorithm define the required steps in order. Once you follow that steps in the order, you will get the desired outputs. Now this is another example for the algorithm. Let's say we want to get the sum of the two numbers. In that case, inputs are the two numbers that you want to input. Output is the sum. Then what are the steps? First you have to input the numbers and get the total and display. Now these are the steps in the process. Now these steps in the process what we call as an algorithm. So that will convert the inputs into the desired output. So in general we can define algorithm is the one which has a set of precise instructions and that should be completed to get the solve the problem or to get the desired outputs. So remembering the algorithm order or the sequence is very important. We have to follow the work in the given order. That order or the sequence is very important in the algorithm. Now this is another algorithm for the sorting. These are we call the sorting algorithm because we sort the numbers in ascending order. Now here we have set of numbers, randomly selected numbers, but I want to convert them into the ascending order. Now to make that one we can use sorting algorithm. Now this is one example of the sorting algorithm. Here there are three steps. What is the first step? Get the smallest number from the input. Now the smallest number is 1. Take that one and remove that one and place in the other side. So place in the other side. Then repeat the steps 1 and 2. Go back to the next smallest 2. Remove that one, place that one here. So like you can see, this is a very simple algorithm which describes the steps to convert the input numbers into outputs where the numbers will be in ascending order. So this is an example for sorting algorithm. And why are we studying these algorithms? Remember, we need to learn this algorithm because all the software that you are running in your computer, they all have different algorithms. If you take the operating system, they have memory management algorithm, CPU scheduling algorithm, file management algorithms, they are available. When you take the data communication networks, routing algorithm, encryption algorithm, decryption algorithms, and the search engine. Now you know this Google is a popular search engine. That is because of its ranking algorithm and searching algorithms, and all the computer games are working with some algorithm, face recognition algorithm, voice recognition algorithm, fingerprint identification algorithm, sorting algorithms. Like there are a lot of algorithms. Remember, all the applications that you are working with today, they have at least one algorithm. Therefore learning this subject is very important. Then basically we need to learn this algorithm. The reason is this: now when the large problems are solved, now we have learned previously system development life cycle. Under that, once you identify the problem, once you collect the requirements, so once you identify all the requirements, you have to analyze these requirements, and once you analyze the requirements, you identify what are the components, subcomponents, how they are interconnected. Once you analyze the requirements, the next thing is you have to develop the algorithms. You have to develop the algorithm and then you have to test this algorithm because same problem. Remember, one problem there can be many algorithms, not only one. Several algorithms will be available for the one problem. Then we need to find out the best solution, and that best solution, let's say you identify this one is the best solution. Then what do you do? Only that one will be coded, not the others. Therefore, once a problem is analyzed, we have to develop the algorithm, and then there can be different algorithm for the same problem. They have to find out the best algorithm. The best algorithm is the one which is going to be implemented. And why do you do this algorithm development? Reason is, now as you know, when the large buildings are going to be developed, what do? They create a model using cardboards or some other simulation tools will be used, and then they will show it to the customer and check whether the customer is satisfied. Then only we do the actual implementation, because otherwise if you just develop a very large building what happen if something is wrong, changing is difficult and you are losing the money. So similarly, when the large softwares are going to develop, first you develop the algorithm and then find out this algorithm is a good one. And once you analyze and identify the good one, then only we developed or code. So that is why we need to do the algorithm designing when the large systems are going to be developed to identify the best algorithm. Then how do you represent the algorithms? Remember, to represent the algorithm, mainly there are two methods. What are the two methods? Flowchart and the pseudocodes. These are the two techniques that we are using to develop the algorithm. So that is, when the problem is identified, we solve that problem by developing the algorithms. So in the algorithm we have the steps. Now these steps must be converted into some format where the other people can understand. Then you have to convert this to the program code. Then only program code will be implemented and run as a systems. So these are the two techniques we are using to represent the algorithm, that is pseudocode and the flowchart. Why are we using these two techniques? Remember, these two techniques are very easy and very convenient and everybody can read and understand, because when the algorithm is developed, the others, everyone should be able to read and understand. In the pseudocode and flowchart, they don't have very complex rule or syntax, therefore anybody can read and understand and easy to modify. So that's the main reason why are we using these two techniques. So if somebody asks what are the advantages of flowchart and pseudocodes, you can explain that. In flowchart is a kind of graphical representation where people can understand easily, because as you know, the graphics or image will give you thousands of information than you are writing paragraphs. So this one, when somebody see, he can understand how this algorithm is working. This is the one of the very easy way to explain the your algorithm. So in this one, we have set of symbols that you should familiar with, and then there are few symbols. Once you know that one, very easily you can develop the algorithm. So now these are the symbols in the flowchart. You should know these things to develop the algorithm. Now initially we have this process. Process means some calculation. When you are doing some calculation, we need to use a square or what we call the rectangle. So that will indicate some calculation, some processing parts. And all the inputs outputs should be written by parallelogram. This symbol is used for the inputs and outputs. This is basically used for decision making. Now later we'll discuss the selection and the loops. For the selection and the loops, to make a decision to do something or not to do something, for that one decision making is done by the symbol called as a parallelogram. The diamond shape is used. And this one is connector. If the diagram is going very large, you can connect the flowchart with one part or another part. Now this is the one which will be used to start and the end of the algorithm. So arrows are used to make the direction, to which direction data is moving, instructions are moving. That is represented by these arrows. So main advantage of this flowchart is, which is very easy to read and understand, non-technical people can understand, and easily convert to the program code, and easily you can make the changes, and logical reasoning can be done more clear and easy to understand. Problem is it takes more time to draw this one, and there are some different tools, but these tools are expensive to draw the flowcharts. Those are the disadvantages of the flowchart. Then other one is pseudocodes. Now in addition to flowchart is a pseudocode. Pseudocode means we are just writing the simple English language to write these steps. Why we use a pseudocodes? Because pseudocode doesn't have any rules. Then once you just write the algorithm steps by just English language, anybody can read and anybody can understand. Therefore, easy to make the changes and nothing will be losing. Just like you are building a building using the cardboard, nothing will be lost if there is a problem. Similarly, when you develop the pseudocode algorithm by pseudocodes, we are not spending a lot of time. If there is a modification, you can modify. We are not losing anything. Therefore, pseudocode is the one which is very easy for the other people to read and understand, and again easy to modify. That is why we use the pseudocodes. Now this is very simple example just to explain pseudocode and the flowchart. Now let's say we want to calculate the area of the rectangle. For this one we are asked to draw the flowchart and the pseudocode. Now the flowchart is this. You have to start. First you have to get the length and the width of the rectangle, and then calculate the area just by multiplying those two, and then output the area and out finished. So these are the steps of the algorithm which we need to follow to get the area of the rectangle. Same thing you can write by algorithm, by pseudocodes. The begin, we have to start, input the value, length and the width, calculate the area and output end. So this is begin is represented by this symbol, end is represented by this symbol, and inputs are parallelograms, outputs are parallelogram. Outputs are parallelogram. This is a calculation. So calculation is a rectangle process. So that is how you can draw the flowchart and the pseudocodes for the given question. It's not difficult, easy, you can understand. Only thing you just familiar with these symbols. Then the control structures. Now remember, in algorithm these are the very important parts. Control structures. Most of the complex algorithms are developed using these control structures. So these control structures are, there are three: sequence, selection, iteration. Now remember, all the algorithm has this sequence. Every algorithm this must be there, but these two may be available, may not be available. We can't say exactly whether it is there, but every algorithm which should be there, sequence must be there. Sequence means step, the order. We have to run the program algorithm in order, in a sequence. The sequence is normally represented by this arrow. Sequence is represented by this arrow. So then remember, this arrow is the one which represents the sequence of the algorithm. So every algorithm we have a sequence, but the selection and iteration of the loops may be available, may not be available. Now the selection is, if the selection is there, remember, or if the iteration is there, this symbol must be available. If this symbol is a diamond shape is available, that means whether there is, maybe there is a selection, maybe there is iteration. Then how do you identify whether which one is there? So if there's a selection, then you can see there's a this loop, this diamond shape, and there are two paths: true, false, yes, no. If it is true, you get a one path. If it is false, you get another path, and then go to the end. So that's a selection. But if there's a loop, then again the same symbol is available. If it is true, it goes in a one path, but remember, if it is a loop, it will come back. It will come back to the condition. If it is coming back to the condition, then you should understand it's a loop, iteration. So this is a loop or iteration. If it is false, exit. So that is how you identify the loop or selection, by using this symbol. So this one is a selection, this one is iteration, loops. Now we'll discuss a little bit about these three in more detail. Now sequence, as I mentioned earlier, every algorithm has a sequence that is represented by this arrow. So then here the sequence is from beginning to end in this order. This is sequence. So every algorithm there must be a sequence, because order is very important in the algorithm. But selection may be there, may not be there. Selection, you can see now, if you take a junction, you need to have a selection. That is, either you are going to straight in this path, or whether you take a turn this direction. So there's a decision making. So based on your requirement, you have to make a decision. So decision making is represented by this notation. This notation. If it is true, one path. If it is false, another path. Here, based on your requirement, either you go this direction or you go to this direction. That decision you have to take. And then how do you write this one? When you're writing this selection, you have to use the word if and this condition, and you have to use the word then. If the condition is true, this will be executed. else mean condition is false, this part. If the condition is false, if this condition is false, then you execute this one, and you have to say if condition is finished. This is how you write it. Now we'll take some example, then you can understand this in more detail. We'll take very simple example. Now here we are given a flowchart. We input the age, and if the age is greater than 55, if it is yes, you can say you are retired. If it is not less than, if it is not greater than 55, you will just say keep working and then finished. Then how do you draw the corresponding pseudocode for this? Begin, this one, start, read the age, let's read the age because it's input operation. Now this is a condition is this one. So that's a condition here, if age greater than 55. Then you can see this one is used to represent this notation. When you have this notation, that is if, because it's a yes no selection. If it is yes, you have to say the retired. Else means condition is false, you have to say keep working. And if condition must be terminated, and end. And the other things, when you're writing this pseudocode, remember this indentation, like you have to change shift like this. This is needed. Why? Because that will make very clear you have written everything clear. Now you can see if we started, else part, end if. Program is started, program ended. Now you can see everything is clear. You can identify whether everything is clearly open and clearly closed. Therefore, when you're writing this program, this indentation is very important. You have to shift the lines like this to make the program more clear. This is another example just to calculate the, when the number is input, you have to decide if this number is odd number or even number. This is there in your textbook. So once a number is input, now here you input the number and you check this number is even. How do you do that? And you divide by 2. This mod operation means divide by 2, get the remainder. When the number divided by 2, remainder is given by this mod operation. Now if we input the number, let's say n equals 5, then what do you do? We divide the 5 by 2. We know when the 5 divided by 2, you can't divide exactly, 1 is remaining. So this remainder is given by r, remainder. So if the r is equal to 0, that means even number, that means no remainder. If the r is not equal to 0, that means it is a odd number. So from that you can decide whether the input number is even number or odd number. So then how do you write the corresponding pseudocode? So you have to input the number, calculate the mod, and the selection if this is that. If it is yes, even number. If it is not, odd number. And you can see if condition is closed and the program is closed. So that is how you write the pseudocode for the given flowchart. And this is a little bit complex one. This is what we call nested loop selection. That means there's a selection inside the selection. So that's called nested selection. Now in here, we need to enter the 3 numbers A, B, C, and first we check whether A is greater than B. If the A is greater than B, if it is true, what do you do? If the A is greater than B, we check whether A is greater than C. So basically this algorithm is given to compare 3 numbers and find the largest. First you compare A and B. If the A is larger than B, that means A is largest. Then you compare A and C. In that case, if the A is larger than C, that means A is larger than both B and C. That means A is the largest. If this condition falls, that means C is the largest because A is already greater than B. But if this condition falls, that means who is the largest? B. Then you compare B with C. In that case, if the B is larger than C, that means what? B is largest, else C is largest. So then how do you convert this into the pseudocode? Now you take each line, enter, display 3 numbers, get the 3 numbers, and first selection is this one, A greater than B. So that is done here, A greater than B. If it is true, you go to another condition. If it is true, you can see we need to go to the next condition. If it is true, If that is true, you have to say A is the largest. Else you have to say C is the largest. And this else part. Now this if condition closed. If started, else, end if. Now for this is if condition, that means this one. For this one there is else part, that is this one. Under the else part you have to check whether B greater than C. So that is done here. B greater than C. If the B is greater than C, if that condition is true, you have to say B is largest. Else C is largest. And finish. Now this if condition closed. So this if condition is started in else part, and if. Now this if condition is closed and the program is closed. That is how you should write the program in the nested selection. Now this is again more complex one. When the marks are input, if the marks are greater than 75, you have to say A. If the marks are between 50 and 75, you have to say B. If the marks are between 35 and 49, you have to say C. In this one, remember, for this kind of places, there's a range. There's a range. Now this can be done with the switch also. We'll discuss the switch under the when you discuss the programming languages. Now here, when the marks are greater than 75, you have to say A. If the marks given in a range, now how do you do that one? Because there's a range here. Remember, this can be done very easily using the if condition with the nested selection. This can be done easily. See the answer, then you can understand how you can describe this range. So here, this is how you write the answer. Now we have to input the mark. We have to check whether marks are greater than 75. If the marks are greater than 75, you have to say A. Because if the marks are greater than or equal 75 means the grade is A. Then else. Else means, what's the meaning of the else? Now here else means, now here this is marks are greater than 75. When you say else, that automatically determine marks are less than 75. So then you check whether when the marks are less than 75, whether it is greater than 50. So in that case, you can see this describes the 74 and 50 range. Why? Here we just say else. Else means less than 75, that means 74. But here you check with this greater than 50, that means this range is describing. So in that case, if the marks are between this range, you have to say B. Then you have to say else. When you say else, then you know marks are not greater than or equal 50, that means less than. So in that case, we know marks are 49. Less than or equal 50 means 49. And we check whether it's greater than 35, then automatically that's a range of 49 and 35. So when you say else, then determine marks are less than 50, and here you say greater than 35, that means in this range grade is C. Now here when you say else, you know marks are not greater than or equal 35, that means less, in that case F. So very easily you can develop the algorithm for this kind of questions. Okay, then we'll come to the repetitions, or what we call the loops. Now the repetition or basically loops are used to when you are doing the same thing again and again. So you can see these are repetitions like this, it's a loop. So if you do the same thing again and again until some condition is satisfied, which is called the loop. Here also this symbol is used to determine how many times you are running this. And this is a condition. The dimension is used to condition, but it is rotating. You can see it comes back to the same thing. So it's a loop like this. So when until some conditions are satisfied, it runs like this. When the condition is satisfied, you will exit. So that is what we call loops. This is very important in the software development when you are going to do several things repeatedly. Why we use the loops? What are the advantages? So there are two advantages mainly because of the loops. One thing is it will reduce the program size. How does it reduce the program size? Now here I have an example. Let's say I want to print the numbers 1 to 100, like 1, 2, 3, like up to 100. Now if you are going to use a write statement to this one, you have to write this one, write 1, write 2, write 3, out, write 100. Then how many times you write? 100 times. You write the right statements 100 times. If you are going to print the 1 to 1000, we have to use this right statement 1000 times. So in that case, you can see same thing is repeating. Your program is very lengthy and very large. But this can be done using loops very easily. You can just say the condition how many times. Let's say I less than or equal 100. We can have the variable I. You can say I less than or equal 100. Initially I equals to 1. Then this loop, this will be there. Here you can write the right statement. And then this loop is running how many times? 100 times. The same thing you can get very easily. If you want to make this run 1000 times, you just add 0 here. Then this will run 1000 times. No need to write the code again and again 1000 times. So updation is very easy. If you want to run this on 10,000 times, you just add a 0 here. That's all. Then this will run the 10,000 times. Therefore updation modifications are very easy and program size will be reduced. So that is advantages of loops. So under loops we are going to discuss 3 loops: for loop, while loop, repeat loops. Now remember, this for loop and the while loop, always flowcharts are equal, flowcharts are same. But the pseudocodes are different. But in general, the flowchart for the for loop and the while loop will be same. There is a condition. If the condition is true, you execute the things and come back. If the condition is true, you come back. If it is false, exit. This is the for loop and while loop flowchart. But repeat loop flowchart is different. What's the difference? You test the condition. If the condition true, we execute. Here you can see if the condition is true, we run. And here condition is tested at the beginning. Before we start the program code, we test it, and if it is true, only runs. But here there is no such testing. Your condition is tested at the bottom. That means at least this will be executed once. Then you check whether the condition is true or false. But here if the condition false, never execute. Here if the condition false, never execute. But even the condition true or false, at least one time this program code will be executed, and then check the condition. So the one difference is here condition is tested at the beginning, here condition tested at the bottom. The other difference is if the condition true, we continue. If the condition true, we continue. But here if the condition false, we continue, not true. Remember, when the condition is false, we run it. When it is true, exit. Here when it is false, we exit. So that's the other difference between for loop, while loop and the repeat loop. So basically difference between the repeat loops and these two loops. These two loops are similar. This one is different. Okay, then we'll take each loop and see how they are working. So initially we start the while loop. So while loop is one which can be used in many programming to solve the problems. In general, syntax is you have to have the initial value to initialize the while loop and the condition. When you're writing, we write the word while and the condition. So if the condition true, executes. So if the condition true, it executes and come back. But whenever condition is false, exit. If the condition false, it execute and continue. So we'll take the example and then see. Now let's see how this simple example works. Now in this example, we have while loop. Initial I equals 2. If the I is less than 6, this is the condition. If the I is less than 6, we run it and print the I plus 1, and then I is incremented by 2. Then here I is incremented by 2, and then come back. This will be continue until while the I is less than or equal 6. So then you can see first line is just mapped here. Is the condition just mapped here. If the condition is true, we have to do this 2, and the other one, if it is 6, finish, exit. So if the condition is true, do this one and come back to the loop. If this is running, if the condition is false, exit, go to the end. This is how it works. Now let's see how to get the output. Now initially I equals 2. We check whether I is less than 6. Yes, 2 is less than 6. True. Then print I plus 1. I is how much? 2. I is 2. Then print 2 plus 1. 2 plus 1 is 3. It prints 3. But remember, I is not changing. I is still 2. Here we just increment and display. 2 plus 1, 3. Then the print 3. Output is 3. But the value of the I is still 2. Then I is incremented by 2. Current is the current value of the I. Current value of the I is 2. 2 plus 2 is 4. Otherwise you may confuse this one. This is only incrementation only for printing. Not the value of the I is incremented. Value of the I is incremented here. I is initially 2, then I is incremented by 2, then it becomes 4. Then I is 4, then you come here. Is the 4 less than 6? Yes. Then print 4 plus 1, that means 5. Print 5. I is still 4. And then increment by 2, then 4 plus 2, how much? 6. Then I becomes 6. Then 6 less than equal 6, this condition is true. Print 6 plus 1, 7. So output is 7. Then increment by 2, 6 plus 2 is 8. And get the 8. Is the 8 less than 6? No. Condition is false, exit. This is the output you get. This is how you get the output for the while loop. Then the for loop. Now remember, the for loop, while loop, flowchart is same. But the pseudocode is different. Pseudocode we just write while and condition. While condition is true, we execute it. But in the for loop, we just write the starting value and the last value, but no conditions available. Here there is no condition. The while loop we write the condition, this condition. But remember, here we don't write the condition. We just do the starting and the end. In that case, we're not converting, because when you're converting this for loop pseudocode in the flow chart, we have to take the starting value I equals 1. Starting value should be placed here. Starting value should be placed here. What is the condition? I goes from 1 to 10. So the last value is this one. Condition is this, I less than or equal to 10. This is a condition. Now this condition is not given here. So you have to get the condition I less than or equal to 10. This should be placed here at this point. Condition is coming from this last value. And this is the body of the loop that will just go there. The body of the loop. And here you can see there is no incrementation. If you look at the while loop, there is an incrementation of the variable I equal I plus 2. So such incrementation is not there. So here we should know I go from 1 to 9, increment by 1. So that updation should be added to the end of the while loop or for loop, each body is executed. This updation must be done. That is I equal I plus 1 incrementation, that should be added to here. So then you have to be careful when you are converting the pseudocode of the for loop to into the flow chart. We have to have the starting value that should be initialized here. Condition should be identified here, and the loop incrementation that should go here. This is another 2 example. So this will go from row I equals 1 to 10 and output I. So the output will be 1 to 10. And the same thing, but I equals 10 to 1, down to means reduced by 1, then 10 to 1, that is 10, 9, 8 to 1. So this is the output you get. So this for loop is working in simple way, but when you are converting to the flow chart, you have to be careful. Then the last one is a repeat loop. Now the repeat loop, as I mentioned earlier, this is much more different with compared to the for loop and the while loop. So what are the differences? Here the condition is tested at the bottom, but in the for loop while loop you should remember condition is tested at the beginning. If the condition true, we continue, but here we check the condition at the end. That means the code body will be executed at least once, then only check the condition. And the other difference is, if the condition false, continue. If the condition true, exit. But for loop while loop, it is the other way. If the condition true, continue. Condition false, exit. But here it's a totally reverse. Now these two loops normally available in these two languages, Pascal and the basic language, but most of the language is not available. Now in here, when you are writing during the flowchart, it look like this. How do you write the syntax? You have to use the word repeat. Repeat, this should be P, repeat, and the condition until. Here is the condition. This is the condition you have to draw right here. This is the condition we should get here. But here just write the repeat word to indicate the repetition, to indicate the starting point, and condition will come to the bottom. So this is another example where you get the infinite loops. Infinite loop means a loop which is running indefinitely without stopping. As an example, if you take the servers are running in every 24 hours, 365 days, always running. To develop the server, these infinite loops are needed. And there can be some applications which are always running. If you take the traffic light systems, which is always running the cycle, so in that case they are running all the time. That is again infinite loop. If you take the ATM machine always running. Once you input the card, it accepts. That means service always running. So in that case we need to use infinite loops, a loop which is running continuously without stopping. This is an example where you get the infinite loop. Here the count is 1 and the condition is count is equal to 0. Then you can see count is 1 means 1 is equal to 0. No, this one equals 0. Then the count is incremented by 1. Then the count will be 2. Is a 2 equal to 0? No. Is 3 equal to 0? No. That means this is an infinite loop. This loop runs continuously without stopping. So in a while loop, if you make the condition true always, you get an infinite loop. Then the other part that you should know, sometimes this selection and the loops can be integrated. So this is one example to calculate the factorial value. The selection and the loops are integrated. Now you can see here there are two conditions. This is the one condition and this is another condition. Now when you see this condition, we know these conditions are used in the selection or in the loop. Then you need to identify which one is which. So here you can see if it is yes, one part, if it is no, another part, and that means no repetition. This is a selection. But this one, if it is yes, you can see it goes like this and come back. So it goes like this and come back. Then you should understand this is a loop. Therefore this you can write using a while loop easily. So then first line is read the value, set this one, and this one is a selection. If the n is equal to 0, then you have to, if it is true, just set this fact. Else means no part, else means this part. If it is no, else part. Under that you have a loop. If it is no, you have to run the loop while. And we have run these two lines, that's these two lines, and end the loop. And if condition is started, else part, if condition should be finished. When the both are all are finished, to print is done. That is how you convert this into the flow chart into the pseudo code when there is a selection with the loop. And this is another one, loop and selection. So here there is a loop and again a selection. Now again you can see there's a diamond shape and there's a diamond shape. Now you need to identify which one is a loop, which one is a selection. You can see this one is goes back and come here. That's a loop. But this one, if it is just this, no, this, that's a selection. Therefore you can easily map, read the value, set these values. This is a loop while this is true, we had to run this lines and loop is over, and loop is over here. Then this is selection. If it is true, this one, if it is false, this one, that is over and then finished. Then easily you can convert into the pseudo code. So here basically we have discussed what is an algorithm, how to represent them with the flowchart pseudocodes, and we discussed mainly three control structures: sequence, selection, loops. Under that we discussed while loop, for loop and repeat loops. So next I'm planning to discuss about the Pascal programming and HTML lessons. Those will be uploaded next. just study that, because for the Pascal programming you need to know this flowchart and the algorithms clearly. I'll upload those into my website. You can just visit there and then see. And those who are coming to my class, just send this information, your name, class ID, which class you are coming, whether it is a O level or A level class. Just send me an SMS to this number just to create a WhatsApp group. And thank you for listening to me. And always you can go to this website, get the information, and then you can subscribe to my video. When you subscribe, once another one is uploaded, you will get the notification. You don't need to pay anything. And work hard. This subject, remember, it's not a difficult subject, easily you can learn. Thank you.